So we just left Maximus Arms over in Franklin, Tennessee, and Mark has brought us here to
Precision Castings of Tennessee.
All right. And
I got it.
Ted Bransford here with us, and he's going to give us a tour, show us how the 1911 is smelted, as we've said a bunch of times.
The schmelting.
The schmelting. And
I think the secret of the Teenage Mutant Ninja Turtles is here also.
It is.
Really? The secret of the ooze?
Secret of the ooze.
That's it.
Alright guys, I'm here with Ted and we're in the wax room now, and he's going to talk about the pattern for the Maximus Gladiator.
Yeah, each of these machines is a wax injection machine. We're injecting molten wax into an aluminum mold to form the part. And this is what we'll use throughout our process. Our process is utilizing the lost wax method. It's been around about 6,000 years. It didn't become a production tool until right after World War II, when they needed net shape parts to drive costs down from fabrications or stampings or other means of manufacturing. So on the 1911, this is what you would get coming out of the frame. And as you can see, it's a blank. We have these odd looking shapes on here, which is a means of feeding the metal into it. These are what we call gates.
Okay.
Which will be removed after they're cast.
So the metal will go into...
will flow into these metal channels, these gates, and fill the part. As you can see, we cast a great deal of detail on the inside. Your trigger bow side, the trigger opening, the hammer, the mag release are all cast to size. Everything for your mag area is cast to size. Yep. We have machine stock on the outside, so we can do multiple variations of the weapon by doing different machine operations. So we take, after we inject them, we take this wax pattern. Now we'll set it up onto what we call a tree or an assembly, and then that'll go into our dip room.
Okay, so step 2 in the wax room, we're going to the wax tree or sprue. And from here, what you're doing is you're attaching the
wax
patterns onto the tree.
Onto the tree and making one assembly. You can see here that the different part, different configuration, but same principle. We use a hot plate to melt the gate. They'll stick tight glue. She attaches it to the tree. And then she'll use a jeweler's torch, which is generated by hydrogen, and wax welded together. So it's one flawless seam assembly. And now she's wax welding the parts to the tree or sprue. And when she's done with that, this part will be then dipped, and from my hand down will be encapsulated into a ceramic shell. Okay. And once we get that shell thick enough to withstand that thermal shock, we'll melt the wax out. And then you have a void. That's the term lost wax.
Okay. Very cool.
Okay, so now we've got the wax tree made, and it's got the 1911 frame hooked up to the tree or the sprue. And if you stuck this into the kiln right now, it would all just melt, right?
That's correct.
So you have to wrap it with the ceramic layers, a few ceramic layers, which we start right here, right?
That's correct. And this will be our first dip. This is a zircon-based slurry, and it's a very high temperature, very strong. And what they'll do is they'll take this wax part, put it in a slurry. They'll rotate that around and get a nice even coat. This is the most critical dip because what you see here is what you get. Surface finish comes from the mesh that we use in our flour. So we use about a 325 mesh, which gives us about 125 surface finish. So they'll take this and they go into a raindrop sander. We use a zircon sand to cover the first dip.
Now you keep saying zircon based. Is that the same stuff that they make cubic zirconias out of?
That's exactly what they make it from.
So this bat right here, you can get you a big old cheap fake diamond for engagement ring.
That's correct.
If you do it right.
And make you look good.
Yeah,
You guys don't happen to make those here, do you?
No, not yet. But we're looking
not
into
yet.
it.
This is after.
This is after the first.
1911, but it's what it would look like, right?
So you have parts that actually go into shears for cosmetic equipment, rail cars, and then you have barrel liners for the 50 cal, the M2. These are glow ball based barrel liners that allow the gun to operate fully automatic without melting the barrel.
Okay.
And we do thousands of them.
And then after you do this first step, we go on to another slurry, right?
And what we're going to do is we're just going to go through a series of progressively thicker dips.
Okay.
To get the shell the thickness that we need.
Okay. Slurry.
And this is actually a ceramic slurry versus a zirconium slurry.
Okay. All right.
So it'll be dipped once that's dry. You'll get a nice even coating on it.
Almost looks like banana pudding.
Underneath the lime banana pudding.
Till it's getting to be lunchtime.
Then we'll go into what we call our G2, or a little heavier grain. And that raindrop sander will adhere the sand to it. And what this is, this allows the fine grains of the zircon dip to adhere to our backup dip. So it's just an intermediate grain.
So basically, y'all found a way to monetize all the fun stuff you did on the playground as a kid.
That's exactly right.
Play with mud and dirt and sand
And get paid for it.
And you figured out a way to make guns out of it.
That's right.
Which is awesome. Now we were talking about the secret of the ooze. That really looks a lot like an ooze.
No, that's not it.
And I wouldn't tell the EPA about it.
Okay, all right, we'll hide that one.
This is our backup slurries. We might put 3 or 4 dips at this stage on the part to give us the thickness to withstand that thermal shock. So here again, it'll go into the slurry. We'll get a nice, heavy, even coat. Go into a fluidized bed, which will put a heavier grain. And this is a ceramic material. On there, matter of fact, this material is mined in Andersonville, Georgia. There's only 2 deposits in North America. One's in Canada, one's in Andersonville, Georgia. And during the glacier period, as glaciers melted, they pushed that deposit down there.
Okay.
So here you can see the M2s, barrel liners.
The 50 cal.
50 cals. These go in paper mills, and these go in rail cars.
And then eventually we get to this point over here. This is as much dipping as... Okay, I know all the trolls on our channel are going to see this shape. What is this?
This part actually goes on the Bradley as an armor personnel carrier.
Yeah, so it's a Bradley tank piece.
That's it.
It's not what it looks like.
And that's made from the same metal that the Maximus Gladiator is made from, right?
A lot of them are, and being a custom job shop, we can pour anything. Anything can be poured in air, so we can pour low alloy, high alloy, nickel base, cobalt base, bronze, brass, and aluminum. What we've done here is encapsulated those barrel liners for the M2 into a ceramic shell. We still have the wax opening here, and we're going to melt all that wax out through that opening.
So all the stuff that left hand showed you with the wax tree is underneath the ceramic.
That's correct. And when we melt that wax out, then there's a hollow void that's left of the exact configuration of the wax pattern.
Okay. And how exactly do you melt the wax out of there?
We use an autoclave system, which is a pressure vessel. Wax expands and contracts with temperature, so the shell doesn't. So as it melts, if you don't have pressure around it, your shell will actually crack, because your wax will expand and crack the shell. So we dump about 110 pounds of pressure, steam, into that vessel that holds the shell together while the temperature melts the wax out.
Awesome.
Then we take that wax, we recycle it, and it gets sent back in the same form, so we start the process all over again.
All right, so now we get to go see some molten lava, right?
That's it.
Go see some hot metal. That'll work. Hey, left hand.
Yeah.
hot in there. That is 1911 frames, or at least the ceramic where they're going to get poured.
Those are the frames.
Is it red? All right, so now we're up here above where they're going to pour the steel, and Ted's going to tell us a little bit about what's going on down there.
Yeah, what we're doing is we're getting ready to pour off a heat, about 700 pounds of 17-4 at about 2,980 degrees. And this is what we call our casting operation. And you'll see, it's pretty neat.
Yeah. I'm already starting to sweat.
Yeah.
Process. What are they doing right now?
Right now they're bringing the molten metal up to temperature. We have set procedures for each part that we pour. It has to be poured at a certain Fahrenheit.
Okay.
So you see that the induction furnace is cranked up. They're getting ready to take a at the immersion parameter. They're getting the reading. The reading will come up here on the digital readout.
900 degrees is what it said?
Now, actually, he burnt the temp off of that, and that was an erroneous reading, so he'll re-tip it.
So it's 104 just standing out there.
Yeah, very, very warm up there on the pad.
That's the need for those suits.
2938.
2938 Fahrenheit.
That's quite a bit different than 900, isn't it? That was an erroneous reading. What's it got to be to pour?
I think he's probably going to pour about 2948.
Okay, so another 10.
Anytime you are.
All right, guys, so here we go. We're getting ready to see the pour.
The gentleman on the right is what we call our pole man. He'll be bringing the shells out to be poured into.
Does he hate having that name?
Well, that's better than the dummy end. On our pouring shank, you have one gentleman on the end that just holds the weight. The other one does the pouring. So you have the pour and thus the dummy end.
Okay.
And then the guy on the pad is our master melter.
They keep it simple, right?
Keep it simple.
So if you had us do this, you'd end up with 2 dummy ends.
It would be jackwagons.
We affectionately refer to that as the 3 stooge syndrome. What they brought out here now is the transfer ladle. That transfer ladle is at 1900 degrees Fahrenheit. So now they're going to bring out the shell.
Ooh.
Those sparks. Man, look how bright that is.
They'll set one shell, they transfer the metal over, and then the pour into the mold.
They're doing this at a pretty good pace.
Yes, these guys work really well together. They pour everything from chicken processing equipment to Hellfire missile parts.
Oh, wow. That's not a prospect.
Wait a minute, so you're saying our Hellfire missiles are made of chicken processing equipment?
Actually, the exact same metal.
The exact same metal? Same metal that these frames are made of, 1911 frames from Maximus.
That's correct.
So 1 bucket per
assembly, yes.
Okay.
Per shell or mold.
Per shell or mold, okay. Man, I can't look at that. It's like lava, man. How does that compare to the heat of lava? You know?
I would imagine that you're probably about
hotter, isn't it?
About 800, 900 degrees hotter.
Wow.
Well, it feels like it's increased about 20 degrees from up here where we're standing.
Yeah, it's already gotten hotter.
It's very warm up here.
Yeah. And how many gallons is in that?
That's a 90-pound ladle.
90 pounds?
And he doesn't pour everything into the mold, but he's pouring about 56 pounds into each mold. Okay. So we get 8 1911 frames per pour.
So 8 1911s per pour of that bucket.
That's correct.
We got 4 going so far. This would be the 5th one.
And then what's the step they go to after this?
They go in what we call the shakeout.
Okay, and that's that pneumatic hammer?
Pneumatic hammer, and what it does is it vibrates and the shell falls off. The shell, as it solidifies, or as the metal solidifies, the shell becomes weaker and it becomes brittle. So when they introduce the vibration to it, it just cracks and falls off.
I'm gonna get as close as possible without the camera melting. Ooh, it's hot. So these are 1911 frames from Maximus Arms.
That is hot right there, guys.
All right, so now what they're gonna do is they're gonna take, the 1911s are still a little hot, so they can't take it in the pneumatic hammer yet, but we've got some ambidextrous thumb safeties that basically they're gonna take the ceramic part and it's gonna be a pneumatic hammer that hammers it off, and then you're gonna end up with these here. You can kind of see it right in there. Ooh, was that supposed to do that? I didn't just ruin a whole thing of thumb safeties.
You break it, you buy it.
Except the pneumatic hammer is going to do it a heck of a lot better than I'm doing it right now. I'm being dainty because I'm scared to break something.
Yeah, don't want to bend it. Alright, so he's going to be hooking it up to the jackhammer now, the pneumatic hammer. And those are the safeties. Just like that. There they are. All right, so after this process, where do we go to next?
We go over to the cutoff area and we'll remove these parts with a abrasive cutoff wheel. Remove them from the runners, remelt the runners, and process the parts.
All right, let's go check that out.
What we have is we have an automatic cutoff saw and a manual cutoff saw. And what we're going to do is Hellhunter is going to bring over the part you just saw shook out, and we're going to remove the parts using a manual cutoff saw.
Okay, so it's just going to slice the little pieces off where they're supposed to be sliced off.
That's correct.
So this is where he cuts the parts off.
He's cutting parts off?
So this is where he's cutting parts off. Too bad Lorena Bobbitt didn't have a machine like this.
What? Old. The brave man right there. Are you able to recycle that metal from the frame?
That's exactly what we do. We take the heads and gates, we'll remelt them, we'll analyze them, certify them to the specification that the customer wants, and we try to recycle everything that we can.
So you were saying that the reason there's not a lot of sparks in that metal was why again?
Well, 17.4, a precipitating hardening stainless steel, has very little carbon.
Okay.
Usually the carbon generates the sparks that you see when metal's being cut or poured or ground. And it has a lot of chrome, has a lot of nickel, has a lot of copper in it, but very little carbon.
Okay, makes sense.
So how's that work for deli slicing meat there?
Actually, we do work for the deli slicing meat industry, and it's a different type of.
That one looks like it would cook the meat as it was slicing.
That's it.
Cooking,
slice and dice.
Slice and dice at one time.
Okay, I can't figure this out. I'm just gonna. Does it count as muzzling us if I kind of do that? I don't know. But it's cool because I can make the little parts move and stuff too. But this is how they perfected the Maximus Arms 1911 on this little program.
All right, guys, so that's it here at Precision Castings of Tennessee. We're here with Ted. We'd like to thank Ted for showing us around and sharing the process with us. Here's the finished frame of the Gladiator. And next we go to the CNC process.
We can't go to the CNC. It's super secret squirrel.
Oh, okay.
Yeah.
Well,
so we'll just go back to
that part
Maximus
remains
Arms.
a secret, but you get the idea of everything from here. Ted, thank you so much.
It's been a pleasure. Thank you.
Appreciate it, Ted.
Nice
Thank
meeting
you.
you.